You should feel pretty confident about centrifugal pumps now. You know a lot about both external and internal components and have a good sense of their basic functions. Let's keep building on that knowledge. And in this section, look at how centrifugal pumps are classified.
This is the fourth section of a four-section module on centrifugal pump principles. This section covers classification of centrifugal pumps. All centrifugal pumps operate on the same principles, regardless of the actual work they do, whether it's low to high pressure pumping, moving light to heavy fluids, pumping small to large volumes, or whatever. What distinguishes one pump from another is size, shape, and basic design. Design is most important.
Pump design features normally considered in classifying pumps include shaft position, bearing position, type of impeller, number of impellers, volute design, and fluid flow. You'll hear the terms vertical and horizontal when centrifugal pumps are talked about. The terms refer to the position of the shaft during the pump's normal operation.
Shafts in vertical pumps are perpendicular to the ground. The driver is usually positioned above the pump. Shafts are parallel to the ground in horizontal pumps. The driver is usually positioned beside the pump. Two other important terms are overhung and between bearings. They refer to the position of the impeller in relation to the bearings. In overhung pumps, the bearings are located on one side of the impeller. In between bearings pumps, the bearings are located on both sides of the impeller.
Pumps are classified as either single or double suction. Both terms refer to the number of suction eyes in the impeller.
In single suction impellers, fluid enters the impeller only through one side. In double suction impellers, there's a suction eye on both sides of the impeller. Fluid enters the pump through a single intake port, but it's then directed toward both sides of the impeller. You already know about single and multi-stage pumps. The number of impellers is the distinction here. Obviously, single-stage pumps have only one impeller. Just as clearly, multi-stage pumps have two or more impellers in series on the same shaft. The purpose of multiple impellers, as we learned earlier, is to produce higher discharge pressures than is normally possible with just one impeller. Volute and diffuser are also terms you now know. They describe the area in the centrifugal pump casing where the kinetic energy of the fluid is converted into pressure. In volute pumps, the casing forms a chamber, or a volute, that's wider at the discharge port than where the fluid leaves the impeller. In diffuser pumps, instead of a volute, there's a diffuser with stationary vanes that form a series of widening chambers. A couple of terms used to classify centrifugal pumps that we haven't covered yet are radial flow and axial flow. In radial flow pumps, the impeller is designed to direct the fluid out at a 90-degree angle from the shaft. In axial flow pumps, the path is parallel to the shaft. Strictly speaking, axial flow pumps aren't centrifugal because they don't use centrifugal force to add energy to the fluid or to convert the velocity of the fluid to pressure. Axial flow or turbine-type pumps are nevertheless frequently classified with centrifugal pumps because their parts and maintenance requirements are similar.
We've got a lot of terms, right? And one by one, we can understand each. That's important to remember because a specific centrifugal pump is classified by which terms are applied to it.
For example, a vertical overhung single suction, single stage radial flow volute pump with a closed impeller. That's one centrifugal pump. Another one is this one. A horizontal between bearings, single suction multi-stage radial flow volute pump with closed impellers.
Each word has meaning. Each is important. All will be needed in selecting a pump for a specific application. It's simply a matter of looking at each aspect of the pump, the way an impeller is made, the type of casing it has, whether it's horizontal or vertical, and so on. In other modules, we'll look at maintaining and selecting particular pumps for particular applications. But for now, we'll close our program on the principles of centrifugal pumps. Review your student manual. There's a lot of information to absorb. Review the sections of the tape again that you need some clarification on, and feel free to ask your instructor for more help. Remember, the use of centrifugal pumps in the oil and gas industry is widespread. The more you know about their design and operation, the better you'll be able to do your job. See you soon.